Hey guys, just wanted to show you another example of a sinusoidal word problem. And this one's pretty simple. So this is going to be on page 49, and it is number 4 on that page. Okay, so this problem is actually very straightforward. It says, hey, if the equilibrium point is y equals 0, then this equation y equals -5 cosine pi over 6x models a buoy bobbing up and down in the water. Okay, so if you don't know, a buoy is kind of a float that they use in oceans to measure distances and stuff. Okay, so they mention, hey, I want to know where the buoy is at time 0 and time 7. This one's super simple. They've actually given us the equation already, right? It's right here. They've given it to us. So for part A, I'm simply going to go, let me plug in the t values, and those are going to go in there for my x values. So pi over 6, and it's going to be times 0 for the first one. And if we just kind of work this out, I know that means -5 cosine of 0. Well, this time, this is actually on the unit circle, and we can just kind of find the value we're looking for cosine 0 from the unit circle, and that's going to tell me that it is 1. So now that I've kind of said, hey, cosine of 0 is 1, -5 times 1 is just -5. So at 0, the height of this buoy is going to be at -5. And then let's look at the second part of this and just see if we can get t equals 7 as well. Y equals -5 cosine pi over 6 times 7. And that's going to give me 7 pi over 6 inside of my cosine. So once I've got this, I'm going to look at my unit circle for the value for this, right? Cosine 7 pi over 6. And that is very simply going to be, I believe it's -√3 over 2. So now I've got -5 times -√3 over 2. Simplify that down, and you've got your final answer, 5√3 over 2. Okay, and so that's it for part A. Guys, we plugged the number in to the equation, and these were friendly numbers, so we were able to work out the answer using just the unit circle. All right, and now that we've got part A, let's take a look at part B, see if we can solve part B. Now, part B says, hey, what's the maximum height and the minimum height? Well, your amplitude for this is 5. And there doesn't appear to be a vertical shift. Okay, there's no d value here. So you start from 0, and your graph can only go up to +5. So my max value is going to be 5, and my minimum value is going to be downwards 5 from that same 0 marker, and -5 will be my minimum. Okay, so that's easily the solution for part B. Part B goes super quick here. All right, so we know the amplitude, but vertical shift is my starting point. I just add and subtract the amplitude to get those. All right, and let's take a look at part C. Part C is asking me for the period. Okay, well, guys, the period, we calculated that previously. Your period is 2 pi over b. So if you look back at your equation, right, your b value was pi over 6. So let's just plug everything in, 2 pi over pi over 6. And solving this out by hand, we can take the bottom number and we flip it and we multiply. So I'm going to have 2 pi times 6 over pi. And immediately you get these happy feelings because our pi's cancel out. And 2 times 6 is 12, and this is going to be my period. All right, so guys, I went through this one super quick because honestly, it's pretty straightforward. Okay, part A was just plugging in the t values in place of x. And I even got numbers that were on the unit circle, so I could solve it using that. Then on part B, I just used the amplitude and said, hey, I'm going up 5 and down 5 to find the minimum and maximum values for this. And part C said, hey, calculate the period. Well, we've done this a million times by this point. We just take the B value, plug it in, and solve it, and we got our period. Okay, so this is a great example of how these problems don't necessarily have to be super complicated. There are a lot of easy pieces to this as well. Okay, we didn't even have to make a graph for this. We were able to just rely on the equation, and we could even solve it by hand.